start. Thanks for coming. We've had a couple of days now just to think about the modeling side of things. I've sent in a couple of tutorials in terms of like the time series analysis. There's a couple of different sort of models we could use. I'm not sure if anyone's attempted anything. I'm trying to put together something in my spare time at the moment, just in terms of the time series analysis. And last time Michael was running a couple of quick models on the data he had, as was always. And I've had a couple of messages on Slack just to talk about the various different methods of feature engineering. A couple of people, I believe, still are working on the feature engineering, which is absolutely fine because it is an iterative process. We can, create a couple of features, maybe, put them to the test and see how it works out. And if it doesn't work out very well, if it's not effective, we can go back over it again and adjust the features. So, if you are working on feature engineering, don't worry, you're not behind. It's just, this is part of the process now. The feature engineering and the modeling go hand in hand. There's a million different things we can try. And it is, it can be one giant rabbit hole that we fall down. But, we'll, there's plenty of things to discuss in terms of the modeling. Does anyone at the moment have anything that they want to share? Any work they've done on either feature engineering or modeling? I'll just allow people to share the screen. Always, you can share your screen. Go ahead.
Can you guys hear me?
Yep, I can hear you.
Okay. So I've been working on the feature engineering of the accident and vehicle data merged on the accident index. So I will just go through the few things. This is the accident data and vehicle data merged on the accident index. Feature engineering of feature pre-processing engineering. So it's almost similar to the previous notebook that I've shared, just with a couple of changes. So in this notebook, we can see that there are a lot of missing values and columns. So what I did is that columns that had more than 75% missing values, these columns, I dropped them. I dropped these columns completely. So then we are left with this, and then the rest. I implemented this column transformer. So in this, I am categorical features. I'm imputing them with data missing, and the numerical features I'm imputing them with their mean value, and the target variable or accident severity, it is encoded ordinal encoder. So this is after the imputation, and this is the final data set, and this is after scaling the data set, and then I tried to implement the random forest on this, and on this data on this notebook too. This is the merged notebook, and this is the notebook that I presented during the previous meeting. So one thing to note here is that then the notebook that I presented during the last meeting session, it returns 85% accuracy, which we talked about in the previous meeting, and this one is returning 87% accuracy. And then I was trying to this is the few features that are contributing the most to to the model feature importance, and these are the these are the features, and this is how much each feature is contributing to the model. And then I was trying to plot the ROC curve. It generates an error, but uh, this is I think it is half, not completely compiled. But there is one thing that we can see between these two curves, that if we look at this curve, we can see that it is cornered, sharp cornered, and this one is a bit round. And the other thing to notice here is that this one is flat and this one is curved. So my guess is that this is the curve of the slight accidents, and this one is of the serious accidents. So, and the third one, I guess it's not even plotting the fatal one. So, so the one thing to notice here is that this mode, the merge mode in the merge notebook, the serious curve is more rounded than the other one. So this means that if we combine the fatal and serious together, then maybe we can get even a better curve right here. So yeah, that's all. And that's where I am right now.
That's cool. Yeah. Have you tried attempting balancing the classes yet, or is that to come?
No,
Cool.
I will do it here. I will do it today. I will
Yeah.
upload the notebook.
Yeah. Cool. So it's interesting that the important features, you know, there's only maybe just above 5% of importance on some of these features, which is quite interesting. With the featured importance chart you've got there, I would try and, you know, we'll try it before and after you deal with the unbalanced classes, but all the features that give a, you know, an importance of over 5%, you know, 5% or close to 5%. So all them peaks that you can see, it would be interesting to try and just isolate those features and run
And train a
just them
model on
features
these
on them.
features.
Yeah. That'll be
Yeah.
probably the next step.
Again.
And we can do that before you balance the classes and after as well, just to see how that affects the performance. At the moment, Michael mentioned it last time. I think, you know, with an unbalanced class, the most important metric that we'll probably be looking for is precision. So it'd be interesting to see if you change your metrics into precision, what kind of performance it's outputting then. And once we balance the features, we can take a look, we can compare then the accuracy, the precision, and the F1 score to see what happens. And also, with just selecting the most important features, we can see how that affects the model. I imagine, you know, we've got quite a number of features there, you know, 48 features. So it's, you know, it is a massive sort of data set for the model to digest. And model, you know, machine learning models love simplicity. So I imagine putting those important features just together. So what have we got? 1, 2, 3, 4, 5, 6, 7, 8 maybe, or maybe 6. If we just take the first 6, the highest peaks, it'd be interesting to see how that goes.
I was this code is from a tutorial that I was following
Cool.
data came. So they also did the same thing after this, that they picked up important, and it actually increased the accuracy in that case. But yeah, I will take it into consideration. I will do it.
Yeah, because the feature importance, I mean, what it tries to describe is what bits of our data set, you know, tell the story to get to the target value. What I would do as well, just to give it, if it's possible, just to give it a bit more sort of explainability, Once you've done your sort of feature importance, you've gathered those important features as well, I would then map back in the index column
Yes.
names and map them back in so we can see what they are. And some of them might be very surprising, but it might be also quite obvious. But it is possible if you save the if you pull the column names in a list,
original column names.
you can remap them in.
Yeah, okay. I have them here, right?
Yeah,
Okay,
cool.
I will do it.
Perfect. But yeah, it's really fantastic work. I mean, the tutorials that you've been following have been quite robust, and it's a good sort of example of how effective tutorials can be. And you've got some very important work there, which is quite standard to a machine learning sort of pipeline. But yeah, it's fantastic. We just have to do some more experimentation with various different features and whatnot, and I think we'll have something quite strong. Has anyone got any questions about Oasis work? Or any suggestions to help them along? No? Cool. Very good work always. Has anyone else got anything to share? Any developments or any sort of insights that you've discovered?
I have done some class balancing if people want to take a look at that.
Yep, definitely.
Let me go ahead and share this real quick. Can everyone see? I'm assuming that we need to zoom in a little bit.
Yeah, just a touch.
Oh, go back.
There we go. That's perfect.
Okay, so I'm going to apologize that it's a mess. But this is essentially where where I started to try a couple of different things for imbalancing. So scikit-learn actually has a library that's associated with it called IMB-learn, which is actually based around imbalanced classification problems. And they have a whole bunch of built-in functions that you can access. One of them being a random undersampler. I tried that. The default behavior is that it just attempts to sample all of the classes that are present equally so that they match the minority class, which for us would be fatal accidents. Unfortunately, when it does this, the sample size is decreased so much that the accuracy of the model actually goes down because there's insufficient information to actually accurately predict on it anymore. So we went from about an 85% accuracy overall down to approximately a 40% accuracy, more or less across the board, 40 to 50% accuracy, which is not a great change. However, for oversampling, I decided to go with Smote, which synthetically creates instances of the minority classes. So in our case, it generates a whole bunch of artificial versions of both fatal and serious accidents, and then adds those to the data set, which actually increases the overall size of the data set. So we split it again, and then we run our series of tests. And this actually, we start to see we get some significant increases. We get 86% on decision tree classifier, but the real area where we get value is that our positive predictive value for fatal accidents has increased to 95% at this point in time, which means that we have gotten very good at predicting fatal accidents, which is what we would like to be able to do. Additionally, the random forest classifier gets us a almost 94% accuracy overall, and a nearly perfect positive predictive value for fatal accidents at 99%. It is getting to be very good at it. There may be some possibility now because of the way that the artificial data is being added that we are overfitting. But I have not explored that as of right now. These two tests I just did on just the accident data itself. I also tried running this test on the accident data with the vehicular data merged in. This yet again caused just a slight increase in our overall predictive value, with our best accuracy being about 95%, and actually our positive predictive value for fatal accidents being it is reading as 1.0, but it's really not quite that, but it is very close. Out of approximately 67,000 predicted fatal accidents, it only messed up on 300, so that's a pretty good. So looking at that, the decision tree classifier seems to be, after running several of these, the random forest classifier seems to be maintaining the most accuracy. It also happens to take the longest for all of the models that I have tried. Pulling that out and then parsing the data. I was doing this right before the meeting started. I wanted to actually start looking at like feature importance and see what we can pull out. There do seem to be some features that have some significant importance. However, what they are, I haven't, this graph is useless. It will be better. It will be better in the future. It is fundamentally unusable at this point in time, but it does look like there is some it does look like using SMOTE is providing us with some at least some marginal value. One thing that I'm going to attempt doing is I'm going to attempt doing a train, essentially starting over with a fresh random tree classifier model, and doing a train test and a validation set, and see if that has a different outcome. Another thing that I was wondering is, I think Rich, you had mentioned, I haven't gone looking for it yet, but this accident data only covers through 2010. Do we have accident data which covers further into the future?
Yes, we do.
Okay.
Yeah, I will. I think there's still a link within the time series data. They have the data from 2005 to 2017, I believe. I will DM you that on Slack so you can plug that in.
Perfect.
Cool. It was only because, you know, for the predictive model, what we wanted to experiment with was different sort of dates and different, you know, maybe build the model to predict on the 2005 to 2010 data, and then use a completely different year as a test set and see if the distribution is the same and the model still performs. That was the idea behind it. But yeah, you know, from what the results you found, it would be interesting to see it just, you know, with the whole, you know, till 2017 data.
Yeah, I actually just want to use it as essentially as a validation set.
Yeah,
what I'd
yeah,
like to do
cool.
is use like 2011 through 2015 to provide, like, this is data that the model hasn't seen, that hasn't been SMOTE. We haven't created any synthetic versions of it, and so I think it would be interesting to see how the model performs on data that it hasn't seen whatsoever.
Absolutely.
Some interesting things here. There are a couple of other I didn't try just normal over selection, which essentially just duplicates the existing minority group. minority classes. I didn't try that because I thought that at least with Smote we're getting some variability in it, which I think helps to prevent, in some ways helps to prevent overfitting. But I think with the sheer number of essentially randomly generated minority class selections that are needed for this data set, I think that it may be hard to avoid overfitting just kind of in general.
Yeah. I mean, if we plot some learning curves, I'm sure we'll be able to spot it, no problem. In terms of your bar graph with the feature importance, I'd just there is a handful of features that seem to be very significant in terms of explainability to the target function, the target feature. So I would just put a cutoff in that bar graph to say like anything over 1% or what have we got? What are we dealing with there? Yeah, so we've got about.
I mean, I think another thing, it's hard to parse out right now, and I don't know if you can see it on your screens, but like one of the interesting things that I'm seeing is that some of these features in the middle here are like makes and models of cars.
Yeah.
And I find it interesting that they're like, even though those spikes are very small comparatively to other makes and models, like there's only like this entire area here is going to be all car makes. There's only like 10 car makes that seem to make up any sort of significant difference in terms of feature importance. And so that, like, I'll see what I can't do and see what I can't peel out of the data, out of what I've done so far, and get a little bit of more information. But
that's the thing. I find that quite surprising, because you would associate intuitively bigger and faster cars to be involved in to give us an indication of what kind of accidents they've been in. So yeah, it is quite a counterintuitive sort of observation, and it is very interesting.
Yeah, it may also be, I mean, one of the we unfortunately we don't have I haven't found the data to kind of verify against, but if there's just more voxels on the road, you would assume that voxel would just show up more frequently, and thus would be a more important feature because it's in more accidents, which means it's probably in more fatal accidents as well. And so there, like, some of it is it might be actual important, and some of it may just be statistically important, which is not real world important all the time. So
definitely. No, it's really good good work. Smote is very powerful, and we can see that the randomly generated data it provides is it does generate it in between the sort of scaled values that we've done, and it does seem to be very effective. But it would be cool to see if we can identify if there's any overfitting with the learning curves. I think that's probably the easiest way to see it, just to see how the models are learning. I would suggest as well, try running it through XGBoost. It is quite computationally heavy. And are you doing this off your own system, or are you using Colab or Kaggle?
I'm using my own computer.
Cool. If you've got a powerful enough GPU, I would set the parameter for the XGBoost to use the GPU, and just see if I think it's GPU hist. I think the parameter is. You can use that to basically GPU ID -1. Is that okay?
Cool. So yeah, I have mine set up to currently it is using my GPU.
Yeah. What model GPU do you have?
RTX NVIDIA RTX 2080
Nice.
Ti. Running, it's beefy enough that it makes a difference.
Cool. I believe Kaggle have updated their free GPU systems, and you can actually have two NVIDIAs. I think the A1000s or A2000s, you can have both of them running on it. So it might be I don't know whether or not they're more powerful than your GPU, because yours is quite a beast. So you know, it might be worth just running a particular section of that on the Kaggle 3 one, and see if it reduces the time, or, you know, has any effect on the accuracy or whatever. It's just worth the experiments. But yeah, I think, you know, I'm not entirely sure whether they are more powerful than yours, but yeah, it's cool.
Yeah. Yeah, so that's more or less what I've come with. Does anyone else have any questions about what I did, or maybe how, even necessarily how I did it, just in case anyone needs any clarification?
If you could share your notebook into the Slack, people can take a look and try and run it on their own system, or in Google Colab or whatnot. But yeah, it's fantastic work. That
I'll reopen it. I'll re-upload it into Colab.
Cool.
I had to pull it out because it actually runs slower on Colab than it does on my local computer.
Yeah. That's the thing. I've got rid of my old work laptop because I'm getting a new job. So they're sending me out a new laptop, and it's a Dell Precision 15, and it's got a 32 gigabyte NVIDIA A3000 GPU for machine learning, and I can't wait to get hold of it. You know what I mean? Yeah. So I'll try and run some bits and bobs myself. I should have it this week. So it'll be interesting to see, you know, how it affects on your work. But Oasis, you've raised your hand.
Yeah. So I was doing some research on the vehicles that were involved in the accidents, and if we run the analysis on the vehicles, we can see that the top vehicles that are involved in the top number of accidents by the vehicle that are involved in accidents are Renault and Vauxhall. So can I let me share my screen for. So I was doing some research on it, and I found out that these are the most common cars in the UK. So you can see that Vauxhall and Renault Clio, these are both present in the, like, these are in a high quantity in used in high quantity in the UK, and these cars are uh, known for this unresponsive brake. This is for, yeah, this is for Renault Clio, unresponsive braking. These are these cars. I first of all, I don't know too much about cars because I'm not quite into it. But this is all I found on the internet. So
yeah. I did have a Renault Clio as my first car, and I can confirm, yeah, the braking isn't the best. But yeah, this kind of research, this will help our solution. We can say, based on the accident data that we have between 2005, 2017 or whatever, you know, we found that Vauxhalls and Renaults, specifically the Clio, has been involved in most accidents according to our data set. We've got supplemental material that we've researched and found that, you know, there is reports that the Clio is known for having a issue with stop time, which may, you know, I don't think it's something that we can test, but, you know, it is definitely worth noting within our solution. All this kind of research is valuable. It gives explainability to our observations and all the EDA we've done on the vehicle data set. This allows us to make, you know, educated guesses of what the issue may be. So, you know, it is valuable, valuable
I was
information.
actually looking for the reason that you asked in the previous during the previous meeting, that why are cars of age 7 spiking so much in the accidents. So I was actually going after that, and this is what I found in the research. So this is another vehicle, Punto, I guess. It is also in the top vehicles involved in the accident. And this guy was just sharing a story about while returning back, a big traffic jam, but the issue immediately But point of proof, I again faced the same issue, and this I faced it 4 times in a row. So it's the same thing. There was an instance I could have banged on my kind of, but luckily applied handbrake. So it's the same thing, the
Yeah,
braking issue. So yeah,
yeah,
this is, I just wanted to share it. Yes.
yeah. There's I think at the top of my head there's an English website called Which, and its purpose is to basically rate products, and it does give a list of, I'm sure it gives a list of most unreliable vehicles, and it's in terms of having breakdowns and things like that, but it's also about problems with braking, steering, and things like and other issues that may impact the amount of accidents that that particular car is being in, according to our data. So if you go to, I think it's which.co.uk, and just search for most unreliable, top unreliable cars, or top dangerous cars, or something like that, and I believe they don't just take sort of anecdotes kind of thing. They actually do the research into it, and do a long-term study of I mean, I suppose it's not the greatest study because it is a collection of anecdotal data, but they put it all into one place. So instead of you scouring the internet for individual stories, they already have done that and put it together. Over 500,000 people who have that particular car and what their most common issues have been. So yeah, which.co.uk, I'd take a look at that and see if we can pull it, see if we can match any of the reviews on there with the vehicles that appear in our data.
Yeah, it will be helpful. Yeah,
Yeah.
I will check it.
Yeah, that's the thing. I mean, we can, with part of the process of a data scientist and a machine learning engineer, if you're working for a client, you need to explain what you found in the data, and if you can back that up with proper research that you've found by reputable bodies, it makes our sort of insights a lot more powerful, and we can go to the client and say, we've got these 3 vehicles that seem to be involved in the most accidents between this particular time period. We've done external research and we found that out that 2 of these vehicles in our top 3 have known stopping ability. Maybe they're known for having these particular faults. We can't say with 100% certainty that this is the reason why they're involved in most accidents, but it seemed to be a smoking gun, and it might, the chances are it does reflect on the accident data. It's definitely worthwhile compiling them, and if you could always just keep a sort of list of links you've used and what observations you've made, and we can sort of make a support and documentation for our dashboard in terms of the to go with the vehicle EDA analysis. Definitely, it's great work. But yeah, Michael, your modeling, fantastic. Some really good insights into smoke and how powerful it actually is. I think from that point of view, where we can predict with a very good accuracy for the fatal accidents, if it's not overfitting, we're in a very, very good position. If it is overfitting, we can deal with that in a number of different ways. We can do some more experimentation, but for the first sort of crack of the whip, fantastic work. We're in a really good position. Has anyone got anything? Has anyone been working on the time series analysis at all? I'm going to be helping out on that one. I've uploaded a couple of notebooks on my GitHub, just with the ARIMA and the LSTMs. I haven't plugged in our data, but I've tried to keep it as simple as possible in their notebook, so anyone can take a look. If no one has worked on it, don't worry about it. I'll try and get something done through this week for Saturday, just to show you an example of what we're doing. But yeah, I think for in terms of the predictive model, fantastic job, fantastic. And everyone's brought some very valuable insights to the table, and Michael's work is fantastic. Always, following along the tutorials and learning as you go. It's it seems that you've come leaps and bounds since starting the project, and it's really good work, so you should be proud of yourself, definitely. Okay, has anyone got any other insights that they'd like to share with the group? or any questions for anything that they've seen today? No? Okay, I don't think I've got much to share. As I say, I've just uploaded a couple of templates into my GitHub and I've shared them in the Knowledge Center. I haven't had a chance to take a look at the TSNE analysis. I've just, as I say, I've had to give a laptop back to the government kind of thing, so I haven't had a chance. But I will have something for Saturday, hopefully, and we can just talk about, you know, what effect and you know, observe our data in a high dimension. Cool. Well, if no one has anything to share, or if you don't have any questions, I think we'll leave it there because we're running out of time anyway. As always, I'll upload this video to YouTube, and Michael and Ois, if you can share your new versions of your notebooks with the group in the knowledge sharing section, it'd be great for everyone to take a look and, you know, follow your process, if that's okay. And yeah, Lavanya, please do share your vehicle data notebook. But thanks, guys. We'll leave it there then. Short and sweet. I'm looking forward to Saturday. Good work. Thanks very much, everyone. I'll see you soon.